Hello everybody, welcome back. And finally here we are again. The last time because of the electricity actually my inverter was beeping and hence I had to just end the live there and there. It's time to just simply continue from there on wherever we left and just simply get the remaining things done. So just a sec. This seems to be alright. Hopefully everything's clear. This seems okay, so let's just simply continue from here on. So we covered, we were going through this particular section, exactly how the arrows are drawn. So first of all, we draw the arrow line segments. Once that was done, then we were just simply focusing on the wings. So when it comes to wings, so we get the last 10 second last points. Once we get those points, so we calculate the sort of start x and start y of the second last one, and again x and y coordinates of the last one. So we have the starting value, we have the ending value, and these are two last coordinates that were there. Once we have these, using them we are gonna be getting their vector. Once we have the kind of direction vector of the last line, using that I'm gonna be getting the angle. So exactly it gives us the angle relative to the x axis. Once we get that, so ultimately suppose just a minute, Excalidraw.com. So if this is the x-axis, we got an angle of the line, suppose like this. Once we got this particular line and we got this angle, now we have to draw an arrow over here. So the arrow should be sort of like this, right? So when the arrow is actually drawn, well, this is not exactly the way it should be, but then the wings should be there. So when it comes to wings, so we just simply calculate the wings coordinates like this, and we just simply draw the lines. The question is that how the wings coordinates are calculated. For that thing we are using Cartesian conversion. Simply speaking, ultimately we need the end x, we already have that. So ultimately we need x, that can be center x, of course. That coordinate can be anything, the radius multiplied by cos angle. This angle tells us exactly how much we want, how much should that point be away, or what should be the angle by which it should be actually away. So we have end x, we have the head length, that's nothing but the radius that we actually want, and math.cos, this is where we just specify the angle. In our case we want angle by 30 degree. So whatever line we have, in whichever direction we have, we want that wings should be 30 degree plus and 30 degree minus. So ultimately we should have two wings, top and bottom. So the total angle we have here is just simply related to the x-axis. Once we have the total angle, we are just dividing math.pi divided by 6. So math.pi, so it is around 180 divided by 6, that's gonna be around how much? Math.pi 180 math.pi in degrees, that's gonna be around pi radians. So that's 180 degree divided by 6, so 6 3 jump 18. So ultimately I'm gonna be getting 30 degree. Come on over here, so I'll get the 30 degree. So what I'm actually doing, the main angle that I have, so I'm subtracting 30 degree to that angle, so it will be going sort of lower side, and I'm adding the 30 degree to that particular angle. It's just like that. Suppose I'm drawing something in here, right? So first of all, using this angle that I have, this is nothing but the angle just a sec. Okay, so this is the angle first of all we got. So ultimately using this formula math.a tan dy and dx, ultimately it gets the direction vectors. Once it gets the direction vectors, it tells us the angle relative to the x-axis. So this is the x-axis, and suppose we have a dy and dx in here, the dx and dy, something like that. This is sort of the vector. So it gives us the angle. Once we have that particular angle, so in that come on, how can I put it in words? Keeping it simple, ultimately we use the first formula to get this particular angle. Once we got this angle, so we got the last points of this particular line segment. Once we have the last point of this particular line segment, then what we try to do here, that once suppose we have this particular line, so we want our arrow wings to be 30° in this particular direction and to be 30° in this particular direction. So we know that we want 30°. So if the angle that we have relative to the relative to x-axis, we already have the angle. Suppose it goes on like this, and then this is the angle that we have, whatever angle that would be. If I subtract 30°, so it will be going here to the lower degree. Subtracting, I think that is done, right? So if we subtract, it will go lower. If we add, it will go upper. So this is gonna be minus 30°, this is gonna be plus 30°, and this way we are gonna be calculating the angle. And once we actually have the angle overall using the formula, we are gonna be getting the x coordinate and y coordinate. That's the only thing we are doing. I know it's crazy, but this is just the mathematical part that I myself understood with the help of AI. I had no idea regarding all these things when I started working on this. So that's what I'm doing over here. This is the overall formula, and the x head length. And if you actually talk about mathematical formula, so this is the mathematical formula. Why is this added and we are subtracting here? Because we are going backwards to just simply draw the wings. Apart from this particular thing, we have to just specify the angle over here. Overall angle we have it, but we want 30° less for one arrow, one wing, and 30° plus for another wing. So this way we are just simply getting the x and y axis for the wing 1, x and y axis for the wing 2. Once we got that, we are just simply moving the lines, and that is it. Drawing the lines and the job is done. So ultimately whatever is here just in front of you, there's only one thing, that is bounds. I don't really need bounds when it comes to drawing the arrows. So wherever I have this draw arrow, come on, wherever I have this draw arrow, at that time I don't want to pass this. So let me do one thing, draw arrow wherever I'm using this. So arrow.ts, this is already done, I don't really need that. And at the end of the day, this is actually being used here. And draw arrow, I'm not really passing any bounds, so that's what I wanted. So that's it, done. So we have gone through the arrow section. Let's talk about the diamond, exactly how the diamond is being drawn. This is really simple, easy peasy. Suppose this is the diamond, so you will have x and y coordinates. So you will have x, y, this is gonna be the starting point. You will have the width, so ultimately you will have the width, and you will have the height. GIGST. Once you have x, y, you have width, you have height. So ultimately what you are gonna be doing, you will just simply do nothing but get the coordinates. So ultimately get the coordinates of this, get the coordinates of this, get the coordinates of this, get the coordinates of this. You start drawing the line from here to here, here to here, here to here, here to here, and your overall diamond is gonna be ready. Again, this is how we calculate it. Again, I cannot really show the things in action. Ultimately this is the way we just simply get it, keeping in mind, I mean, should I show that or not? Just a minute. Suppose these are the points that we have, right? We have width, we have height. Now if we want to get this particular wanna get the coordinates of this particular section. So in that case, this is gonna be, first of all, this is gonna be x. The x is gonna be same or not? X is not gonna be the same. X plus width divided by 2. It's just about common sense. And y is always gonna be the same, but this particular point will be half of the width. So width divided by 2 plus x. So ultimately x is the starting point. I'm gonna be adding half of the width to the x, and then I'm gonna be getting the center point. Similarly, I can get this one, and this one, and all the formulas are mentioned over here. And again, if you just pay a little attention, it will be understandable as well. Let's talk about ellipse. So when it comes to ellipse, so drawing the ellipse is pretty simple. That's nothing there is already ellipse method that you can call on the context. Just provide the center x, center y, radius x and radius y, and your ellipse is gonna be drawn. This is it. Apart from this particular thing, if you have suppose x, y, width and height, so again you can get the radius by just simply radius is gonna be half of the width, height and radius y is gonna be half of the height. That's pretty simple, right? If I'm drawing any ellipse in here, so we have and if we have the center in here, so we have the radius y here, we have radius x here, so we have to get the radius x. This radius x is gonna be half of the width and the radius y is gonna be half of the height. So this is how it just simply goes on. Once you have it, you just simply enter the values in here, the job will be done. We are using math.pi multiplied by 2. Math.pi means 180 degree, multiplied by 2 means 380 degree. So ultimately the ellipse will have a 380 degree and ultimately it will be closed, right? Going ahead, we have free draw. Free draw is pretty simple. Pretty simple in the sense we have x, we have y. These are the points that we have. Talking about these points, these are relative distances. What are the relative distances? So suppose this is x and this is y. I started drawing something from here, 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 something like this. I drew this, and now each and here on this particular line we have many points. So this is nothing but the combination of a lot of points, and these points are relative points. Relative points in the sense they are not exact coordinates, rather as I drew. So as I am drawing the line, so suppose I want to get the coordinates of this one. So what I did, that I got the exact coordinate, whatever the exact coordinate using the event, whatever I got. So what the hell, I'm getting a call right now. Just a minute, give me a sec. Alright everybody, welcome back. Having said that, let's just simply continue. So ultimately what I'm doing, I'm just simply storing the relative distances. You can even store the relative absolute points, exact coordinates. That's completely up to you. And there is a reason behind exactly why I actually did this, so, but it's gonna be taking a lot of time. So what I'm gonna do here, that coming back to this, we are getting the points, but they are not exact coordinates. That simply means whenever we are using them, we'll have to get the absolute points, and for that thing we'll have to, whatever points we get, we have to add x and y to them, and then they are gonna be the absolute ones, exact coordinates. Okay, so that's what we are doing over here. We are passing x, we are passing y, and we are passing the point. That particular point needs to be added to the x and y, and then we are gonna be getting absolute points. Again, that's completely up to you whether you go with this way or not. I went with this way, and there are some benefits of having it, and the same way Excalidraw does that. So I just chose this way. And apart from this particular thing, nothing else. We have a lot of points. Yeah, we have a lot of points. Nothing, just draw the line. Draw line from one point to another, another point to another, another point to another. And this way, as you keep drawing a lot of lines, they are gonna look like just a sec. We are gonna be calling this, first of all, this needs to be at the top, something like this. Then we have image cache in here, and cache, get cached image. We have two functions over here. Let's talk about the first function. So image cache dot get, we are just simply getting the image. So you giving the shape dot URL. Okay, so we got the context, we got the shape, we have the URL. Using this we got the image. Once we have the image, and then let me understand this, then only I can just talk about it in here. So we have the image cache, that is a map. It has the string, it has the image element, that will be just simply saved in there. And once this is done, so image cache, so first of all we are actually checking, so image cache dot get, whatever shape I'm actually getting, I'm checking whether that particular image already exists or not. If the shape does not exist, in that case I'm gonna be creating a new image. I'm gonna add the image URL in there, and after that I'm gonna be setting it to the image cache. And in the remaining case, I'm just simply gonna be drawing that. So draw image is the function or method that you can actually call on the context. Provide the image, shape x, shape y, width, height, and the job will be done. Simple, easy peasy. What is actually happening over here, that we are getting the image URL. Of course, I'll pass the image URL. Once we are getting the image URL, we are checking whether this particular image that we are trying to draw in here, does that image already exist. And for that thing we are actually creating a map in here, and using the shape.url, so ultimately image URL, we'll check whether it exists or not. If it exists, that great, we are gonna be using the cached value. If it doesn't exist, then we are gonna be creating a new image, adding the shape.image URL there, and just simply setting it. So shapes URL is gonna be the key, and the value is gonna be the image. Next time onwards, if I try to upload the same image again, as I have this particular map, so cached image will be used instead of creating new object of that particular image too again. So this is how it just simply goes on. So it just simply caches the image and get cached image. If you want to get the cached image, you can just use that, but I'm not using it in here. So you can provide the image URL, it will just simply check it in here, and if that exists, it will just simply give you the value of the cached image, otherwise it will return the image. If it doesn't exist, it will create, otherwise it will return the image. So probably it's being used somewhere or the other. So let me just have a quick look. Well, we are not really using it, but good to have it if you need it in future. We never know whether it's actually gonna be used or not, so we'll see. Then we have the line, pretty simple thing. You have the coordinates, you have points. Most of the time you will have 2 points. Once you actually have 2 points, so just simply draw the line from one point to another. Again, we are getting the coordinates over here, like the fixed, these are the absolute points. What can I actually do? Let's do one thing. This way we get the absolute points, but instead of this we can actually use the, not here, probably at the top. We have the first, so points dot 0, and this is not really bad. We can use that function get absolute points, but in that case we'll have to just create another variable in here. Which one is the better way? Let me just simply have a look in here and how we handle this particular case in here. Absolute point, we actually had to name them, so yeah, we can name them as well in here too. Absolute first, that's good, not really bad. Once we have the absolute first, so absolute first 0th index, absolute first index, and the job is done. The another thing is that type of number is undefined. Undefined is not assignable, so in that case we'll check whether it actually exists or not. If not absolute points, just simply return from here. It's still problematic in that case. Not getting this. What is the issue? If absolute first dot length, if that is less than 2, in that case I have to return, but it's still not problematic. It does exist, so we'll have to clear that the value exists there. Let's go with this. We have absolute points, and I'm gonna be just simply destructuring the value of the absolute first. It won't work like that, so let's go ahead like this too. I mean, that's not really gonna be a problematic thing. The only thing is that the first, what's the better way to name this? We are getting absolute, we will have to just a minute. We have absolute first, right? So in that case, I can use the same function in here as well. So we have to pass the x coordinate, we have to pass the y coordinate, and at the end of the day we have to pass the first from here. Once we passed it, we have the absolute first, and then after that absolute first dot x and absolute first dot y, and this is how it's gonna be done. So apart from this particular thing, we have to get the absolute point in here as well. So const of absolute point get absolute point, and we have to just simply replace this value. So absolute point dot x, same thing is gonna happen in here. absolute point dot y. Alrighty, so this particular thing is done, and once this is done, then okay, no problem. Rectangle, we have xy. Drawing the rectangle is pretty simple. We text. When it comes to text, so we have to draw the text line by line. So ultimately the line that we provide in here, it's like just a minute, you have we are getting x, y, text, font size, font family, all these things. And when it comes to drawing a text to text dot split, line by line we are splitting that. Once we are splitting that, so we are gonna be getting the line and the index values once we get them. So ctx dot fill text, we are just simply gonna be providing a line x, y. This is gonna be the x coordinate and this is gonna be the y coordinate. Y coordinate will be increasing by the number of line. This is how it just simply goes on. So it's not like you are drawing only like everything in one line. In one field text, it can only take one value, and one field text can just simply render one line. And if you want many, you will have to just simply kind of split the lines, and that is it. This just does the job. So these are the what kind of rules, or the way the shapes have actually been drawn, the algorithm behind them. And we've talked about this. Clear canvas is simple, easy peasy. We get the context, we just simply clear the canvas. And apart from this particular thing, we have render shapes. That's really interesting one. Render shapes does nothing but just simply gets the context, shapes, and skip shape ID. Skip shape IDs in the sense how many IDs, how many shapes you actually want to skip. So we are going to be passing an array with the IDs of the shapes, and those particular IDs are going to be skipped if we want in that case. By the way, coming back to this, we have skipped IDs are going to be equals to skip IDs if skip IDs exist and the length is greater than 0. In that case, we are sort of creating a set using the skip IDs, and then we are returning null. There are two things actually that we have been through so far. There is something called new and map, and when it comes to this, it just simply gets or takes two-dimensional array, and maybe see, it is something like this. It takes two-dimensional array, it just simply saves the value. This is the first thing. And the second thing is that new dot set, that just simply set means it will have only unique values. Let me show this in action, or let us try this in action. So in here, const new map, we'll have two-dimensional array here. So this is gonna be A1, B2. Is that gonna be two-dimensional or just one-dimensional array? Let's see. I think that is a two-dimensional array. It just needs to be like this. We'll see. Yeah, map. So we get the map like this, and if we want to get the value, so map dot get, and if the key we have to provide in here, and then we are gonna be getting the value. So this is how map works in JavaScript. It's good to know about this particular thing. And there is something called set. So const set is gonna be equals to new set, and again it's gonna take an array 1, 2, 3, 4, 3, 2, whatever, just like this. If I just simply have set over here, so it only returns the unique values. So these are the two things that I've actually used quite extensively in the project, and that's the same thing we are trying to do in here. So as we get the skip IDs, we just simply create the new again this is nothing but an array, and once we get that, we create a set. All the duplicated values, they just simply get removed, and then we are just simply try to render the shapes. As we are rendering the shapes, so what we are actually doing, if skip IDs, what is that? That's nothing but the set that we have just created. If that has the shape ID, then we have to continue from there. That simply means that's not gonna be drawn, otherwise remaining shapes are gonna drawn. And again, draw rectangle, draw diamond, ellipse, arrow, line, free draw text image, whatever functions we went through, all of them are just simply being used in here. So this should be enough. So these are the things that we have gone through. The draw section is complete right now. Let's talk about geometry. We have quite a lot of things in here. First one, but just a minute. We have bounding box, we have absolute points, it just simply returns the absolute points. We have hit test, that is mainly responsible for hitting test, but the file is quite a long one. In that case we have to, as for we actually have to do what, structure the things better, and especially when it comes to this bounding box, the number of lines 200 or something. It needs to be restructured, otherwise it won't be good at all. We have first of all get a resize handle at point. It just simply gives us the resize handle at a particular point, and get segment handle, get corner handle, get point. So ultimately they are related to bounding box. As for the resize handle, it mainly belongs to this only. So what I'm gonna do, I'm just simply gonna let them be here. Later, if we get time, we will be formatting them, keeping them at better places. How to refactor this. Looking at your project file immediately stands out. Geometry models that 274. That file is doing at least 5 different jobs, computing on recommended. So bounding box, it will have index.ts, get shape bounds.ts. Okay, so inside geometry I will have different, I'm supposed to be having different folders. So when it comes to bounding box, so get bounding box.ts, get bounds from points, get shape bounds, index.ts, hit test is the point inside rectangle circle, index.ts, resize handles, and get absolute points, normalize, and hit test. Not really bad one, we can actually go with this, and again the main things are not really helpful, but this particular file structure, if we want, we can structure it this way and things can be easier. So we have geometry. Inside geometry, let's have bounding box, because some of the things are gonna be related to that. So let's do one thing, create a bounding box folder. Let's structure it as much as we can, and later we'll see what happens. So in this particular file, what all we have get bounding box. Suppose that's gonna be the first one actually. So let's create a file, get bounding box.ts, and once we have it, so it actually needs to be cut and pasted in here. Now of course I need the tolerance and absolute points we need, and shape with points. It's just as simple as that. You have to just simply sort of subtract refactor everything, and again this refactoring thing is something that can be done later on when everything's done, and that is why I'm not gonna be focusing on this much in here. Shapes without points we have to get. But as I have started it, so let's just simply get this over as well. Things that are not gonna take a lot of time, we are gonna refactor them so that things are a bit well looking, and in the remaining cases we'll be just simply ignoring them. Let it be in here. Alrighty, get rid of these. This seems to be alright. Shape with points, don't we have them? I removed it again. That's insane. Am I kidding? Alrighty, this seems to be fine. No errors as such. How about in this one? So this is the first thing that we have refactored. Then get bounce from points. Do we have that here? We have is a point in is point inside rect. Is just simply tells whether the point is actually inside the rectangle or not. Is a point in circle we have. Get corner handler. Get segment handler. Get segment handle. Okay, that's fine. So get segment handle. That's gonna be merely for a line, right? Yeah. And we have get resize handle, and all of them are related to the bounding box and all, are they? Get bounce, get shape bounce. This is mainly for the bounce. Hit test, edge point inside rect and edge point inside circle. So let's just simply have them. Another folder that's gonna be hit test, and the first one is gonna be which one? We have is point inside rect. That's just simply gonna be checking that. So is point inside rect.ts. Let's just simply is point inside rect. Try to refactor it as much as it can be refactored, and of course from tomorrow onwards we have to work on more features. So that would be better if the things are actually refactorable, right? Let's just simply install, import pointer here. Alright, this thing is done. Okay, and what is the next one? Edge point in circle, right? So let's cut it from here. Is point in rect. Is a point in circle.ts. In circle is point inside rect. Let's make it inside circle as well. So is point inside circle, is point inside rect. Once we have them, let's just simply import and export. That is done. Is point inside rect, that is also fine. What's the next one? We have get corner handle. So resize, that's actually related to resize handles. So resize handles, geometry, resize handles, and all these things are actually related to geometry, so let's not worry about that. Coming back to this, get corner handle. Cut. Get corner handle.ts. Again, they are the handles that simply means they are used for resizing only. Is point inside rect. Done. And apart from this particular thing, I'll have index.ts at the end, so that just simply exports everything. And get segment handle.ts. This is the one. Get segment handle.ts. Paste it in here. Inside is point inside circle. Absolute points. Already this is done. So ultimately the files are not that big. That's the only difference. Otherwise remaining things are exactly the same. Then we have get resize handle at point. get resize under that point. This is gonna be inside this only. Get resize handle at point dot is. Lastly, we'll cut it from here. This is the last thing that I'm actually refactoring. Later on we'll do it. Right, this refactoring thing is gonna be taking time. Not taking that much time, but it's better to focus on more functionalities. Once we have worked on them, then we'll start refactoring it. Especially those things can be done later as well, right? But let's see how much we can do right here. Once this is done, let's simply get rid of this. So we have this hit test, we have bounding box, we have anything else that needs to be done. Get absolute points, normalize rect, we have hit test, we have in there, and then imports become there can be many more things that can be done. Now there are so many functions inside this hit test. So hit test is supposed to be here, and then many more. Okay, just a sec. We created this hit test point inside circle. Time to refactor it really well, yeah. This is insane. So this is the first one. As I have started this, so let's finish it as well. Hit test. What was the name? Point in polygon. Keep it here. It just simply returns whether it is inside or not. So we have point in polygon, distance segment, let's give it to the AI so that it can actually give us some suggestions. Help me refactor this. This file is actually better candidate for refactoring. Then ultimately we'll have a shape hit test, generic geometry algorithms, polygon, distance segment. Things cannot be like this. I mean, this big, right? So we have this inside a rect and inside a circle, and just in here hit test of what is the difference between inside in a rect? It just simply takes the point x, y, z height, and this point in rectangle, point tolerance, they are the different ones. They sort of takes the different values, but ultimately do the same thing only. It actually meant for shapes. So hit test, let's create a shapes folder in here, and now have everything in here. So point in polygon for what? For the shape, right? How about creating shapes inside hit test? Yes, actually, okay, that's right. Okay, going ahead. First one is gonna be what? First one can be polygon.ts, rectangle.ts, diamond.ts, arrow ellipse.ts, arrow.ts, line.ts, freedraw.ts, text.ts, image.ts, get pointing shape, is pointing selected shape bounds, that will go to bounding box section, get shape at position, that's just normal functions. So we have this one, image, let's keep it in here. We have text, let's keep it in here. We have free draw in here, point in line, cut, what was that, arrow, ellipse, diamond, rectangle, point in segment, segment, segment just covers any segment for that sake. Distance to segment, polygon, distance to segment, it just simply gives the distance to that particular segment, that's fine, and that can be part of it test only. So geometry, we have hit test. Inside hit test we have is point in circle, is point in recto, and probably one more we'll have, that is distance to segment. Where should distance to segment go? Algorithms, point in polygon, okay, that point in segment, distance to segment, yeah, that's not a bad way. So hit test, we'll have algorithms for the hitting test just in there, not a bad option at all. So we'll have algorithms, okay. Inside this we'll have point in polygon, so that's gonna be, these are the shapes. Polygon can actually be for anything, so let the polygon be in the shape, like polygon can be any shape for that sake, that's fine. Okay. Is a point in polygon.ts, let's just simply keep it in here, or point in polygon, can be anything. Again, this point in polygon will be used later. I have plans of adding triangles and all, many more shapes. At that time, instead of checking them separately, I'm gonna be using point in polygon later on, not now of course. Then what do we have? Distance to segment, point in segment. So even this segment related thing, point in segment.ts. So when it comes to point in segment.ts, shapes, segment, let's just simply paste it in here, and we have point in, distance to segment. That's the last one remaining in there. No, there are more. Get point in shape as well. Distance to segment.ts, and get point in shape. They are gonna be just below the shape. Is point in selected bounds. Get point in shape. Get point in shape.ts. Get shape at position. Get shape at position.ts. Is point in selected bounds. Is point in selected bounds.ts, and the job will be done. Let's just simply refactor the remaining things. It's not over yet. So get point in shape, we have it here. Then we have is the point in selected shape bounds cut. Then lastly, what do we have? Get shape at position. At least we are done with this. Get shape at position. Okay, anything else that we need, that needs to be done in here? I don't think so. Let's try refactoring that. In that case, algorithms, distance to segment. So distance to segment just simply gets the distance of a point from a particular segment. That's what it is used for. And don't worry, these are nothing but the comments. I wrote the comments because that is how I visualized this while working on it. So without the comments, it would be next to impossible for me to keep the things in mind. So I just thought of adding as many comments as just possible. So that is why they are here. Ignore them. We'll explore the logic part very soon. Polygon is something that I'm not using, though I wrote the logic in here. What it does that it throws lots of arrays or line, so lots of arrays, and checks whether they hit a particular shape or not. Having said that, we are gonna be going through it soon. Points shape. I think refactoring is one of the most important thing. Until unless you actually refactor that, things are always gonna be complicated. So it's better to refactor it. It's better to spend time doing this as well. Organizing the things in the best way possible matters the most. Point in shape, interesting. So hit test will have its own type. Geometry will have its own type .ts just for the geometry, and alrighty, we have this particular type in here, and coming back to this arrow, point in segment, algorithms, the spelling is wrong. Why algorithms? Interesting. Alrighty, this seems to be fine. Coming back to this. There are a lot of formulas that got actually used here, so we'll definitely go through them one by one, exactly how they work and all, and at least I can talk about them verbally, and probably in some live stream, and then you can just dig deeper into them with the help of AI and all. So let's see how it's gonna be going down. What the hell? So much. It's even gonna be bigger. Like I have just added the basic functionalities so far. Now advanced functionalities, they are yet to be added. So this project is gonna be huge. And even I'm thinking of integrating what the chat option, meeting option, the talking option as well. You should be able to talk to the people on the other side who are in the same room. So let's see. You can invite the people, ask them join the room. You can sort of let them in. So there are many possibilities, many things that can actually be done. and we are gonna be working on them. At least a month I can give to this particular project. After that, not. Month in the sense max to max till 30th July. That's it. And I think that much time is gonna be more than enough. No suggestion. This is gonna be first project where I'm gonna be working on the longest ever. I already like spent more than 15 days or something since we actually started. I don't know how long it's been, but yeah, many things. It's like almost the basic stuff is already ready. You can anything as basic you can think of for a board, we already have it here. Now more than that is gonna be implemented, but before that I think it's the right time to refactor it well. Done. Done as well. Circle point in this. I'm not getting the sense of having these things here. Like I'd better just simply have inside the same function wherever they are being used. We'll check this thing out. Is point in selected bounds? That makes sense. Good to have it here. Get corners. It's more readable honestly when you have the things structured. Otherwise you just simply keep going through the things here and there. Nothing makes sense. Hit test. Time to delete that. Normalize it. Here we have types. Here we have, and this is how it just simply goes on inside geometry. Do we have some more things inside utils? We have get canvas center, canvas cursor, get size, get text dimensions. Okay, that's fine. They're normal utilities. We have the main types in here. So good that we have gone through this particular thing, geometry stuff. Inside geometry we have the hit test, and inside hit test we have these things. The only thing is that where am I using this is a point inside a rectangle. Get corner handle blur. This is where it's being used, right? So what I will do, this is just for that, so why not keep in that file only. Probably like this. So we have, if something's being just used once, so it's better to keep both the things in the same file. Or the second thing that is is pointing left, that is it, the job is done. So that is better, isn't this? Of course this is gonna be a private function, and because mainly the reason behind removing it that it doesn't look good in here, because we already had a lot of point checkers. And similarly we have this point inside a rectangle. Where is this actually being used? It's being used for the segment. Cut, go to the segment, and why not paste it in here? Just one more function, and that doesn't do much, so it's good to have it here. At least that's what I think. So now we have point in selected bounds. It just simply returns as that. We have point at a position, point get point in shape, and ultimately we are going to be getting the points for these shapes. Then we have all the shape related logic. Algorithms, we have a few: point in polygon, point in segment. They are nothing but normal algorithms that are used in here. Yeah. Alright, it makes sense. Going ahead with the hooks, we have hooks in a proper structured manner. We have canvas, we have history, we have interactions, we have pointer, we have render. Pointer even contains the state. We have renderer, we have texture, we have tool. Inside that we have use tool actions, and image upload, that should be actually part of image that we have in here. So let's just simply keep it in here. Use image upload, use tool actions, viewport. Image is just the outside, come on. In that case, let's get back. Hooks for the image. We have canvas, we have history, we have interactions, we have text. Just a minute. This text has used text editing resize. Then we have used image upload. Let's first of all have it inside hook. Get image dimensions and image grid, image loader. They are just simply extra utilities. Simply for shape, they are the extra utilities. Store, we have transform, again extra utilities. Get resize rector. I don't think this is ever being used. Text. Scale shape in groups. Scale shape in a group, that is really a good one. So whenever we are transforming that, is scaling shape in a group. Scale point in group, we can scale a single point, we can scale the shape. Whenever we are just simply scaling the shape, we are scaling the points at the end, and this does not need to be returned from here. Okay, resize this, resize line, but it does make sense. Free draw, not that big either. Get resize it, sort of enough, not bad either. Types, utilities. Alrighty, I think it's well structured as for right now. Okay, there are many things, probably we are gonna be going through those things late in the morning. Some more like algorithms and all, we will discuss them, but not now. What time is it? 8:47. Features, editor, we have these. And what's the next thing that we want to work on? First of all, let's try running that. We've changed many things, so no doubt we are gonna be getting the errors as well, so time to fix them. Okay, what is the next thing that I was just simply thinking about? Coming back to this, these are the to-dos anyway. The recent shape should always be at the top. This is interesting. The recent shape should always be at the top. First of all, let it load, because I know I'm gonna be getting a lot of errors right now. And let's just simply fix the errors as we find them. Probably we are gonna be refactoring them. That would be better. Use shape hit test. What is the use of this, and why do we even need to have it? Even this clipboard related stuff, later we have it. As expected, there are errors. There are so many functions, around 400 lines of code. You got to be kidding me. I thought it was done. It's not done yet, bro. First of all, let's get it working, fix all the errors, and then we are gonna be further refactoring it. Why just simply takes time to load for some reason. I still have to refactor it. There's a lot of code, and if the code is actually scattered here and there, that might not be the good thing. Alrighty, let's see. Hi there. What's up? That's good. Hi. I'm just simply checking out the things, nothing else. And let's work on some more features. What's that feature? And let's see exactly how we can accomplish that thing. And meanwhile, cling, 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 aged. Okay, what's again? We can just undo. We have this feature as well, so this can actually be done. The thing that I want to check in here, that is, if I draw something here, if I draw something here, and if I just write something here, if I go back in here and draw something here, if I, yeah, we don't see that, right? It just gets under. Fine. Okay, let's work on the next thing. What is that next thing? If we actually go here in this board, again I forgot to refactor it. We have to focus on it. Let's refactor first, otherwise it's gonna be too much. We are gonna be adding more and more things, and that's gonna be one time. Things will feel like a lot. Let's refactor the hooks this time. We have the canvas around 123 lines of code. We have update over use effect, and we have apply resize handler, and these things are being exported from the hook itself, and this apply resize handler should be part of canvas resize. Apply resize handle cursor. So whenever we are resizing, so we have this huge canvas resize and I did not write the code like this, invalidate, or did I? Okay, I did. I even forget. Never mind. So we have the canvas and we are getting the ref. Once we are getting the ref, we are just simply assign the width and height to those refs, and once that is particular thing is done, that is it. One thing that I can do in here, that is let's make it as good as possible. First of all, let me have a look on my on, and then we'll give it to the AI. This part is okay. Update cursor, this is sort of also fine. Selection. So update cursor, forward cursor, and we are gonna be getting the selected shape. If the length is greater than 1, that simply means group selection. We are actually getting the bounce, that will be group bounce actually. Alrighty, we got the group bounce, that's actually gonna be in here. Get resize handle at point. So when it comes to getting a resize handle at a particular point, so we have to just simply pass the bounce there. We don't really, because we might be getting the resize handle for a particular shape as well, right? So this is how it's gonna be going on. Is point in selected shape bounce, and that's gonna be nothing but the group bounce. Is point in selected shape bounce. If there is inside that, so of course we are gonna be moving it. Otherwise, if that is there is a handle, we are gonna be just simply applying it to this. Let's just go through the hooks right now. The main focus is on refactoring the hooks. This is the first hook. Let's give it to the AI and see how it can be better refactored. As for the remaining things, fixing the bugs and all, we are gonna be working on that. Help me refactor this. This is already flarely what flarely came. This is sort of a hook. Utilities get resize handle cursor. Okay, find the selected shape, compute group bounds, detect this, and extract the cursor decision from the application. So what we are actually doing in here, that is we have this apply resize handle cursor, this particular thing. So instead of this, create get a resize handle cursor. Get resize handle cursor inside utilities. Get resize handle cursor.ts, and we are gonna be passing it in there. It just simply gets the handle. Based on that, it just simply returns this. Pretty simple. Paste it in here. That's fine, seems to be right. And what's the next thing? Now get resize handle cursor. if I actually go back when we are applying, so instead of using this, canvas dot style dot cursor. As simple as that. So we can remove this piece of code as well. Anything else that can improve extract selected bounds cursor detection? So get a selection cursor. Get selection cursor. Where are we using that logic? That must be in here only. Get selection cursor, gets the bounds, and returns what? It actually returns this whole logic. Get a selection cursor. Update over this. We have selected shapes, bounds, red blue bounds, and this. So if selected shape is greater than 0, in that case simply means we have to show the hovered cursor, and as we are just simply showing it, we have this logic being implemented here. So get a selection cursor is gonna be just simply it will return either null, it will return or move, or the handle one. That would be better. Let's just simply go with this way. We are gonna be refactoring it even further. The more the better, and the simpler it will get. We have this particular function. That's nothing but the part of the code that is already written. Get selection cursor is just simply gets the point and gets the selected shape. After that, it once it gets the selected shapes, it gets the bounds, and those bounds are nothing but group bounds. Once we have them there, then the bounds are actually gonna be group bounds. And at the end of the day, what we are actually doing, that get resize handle cursor, we will be returning it from here. If that is already inside this, we are gonna be returning move, or we are gonna be returning this. So this is mainly for giving us the selection cursor, and once we have it here, after that selected shape is definitely gonna be there as for this part in here. So the selected shape is greater than 0. Just a sec. So at the end of the day, we are getting the group bounds. We have this, we have this, we have this, all of this, and just simply setting the cursor style. So I'm going to get rid of this part from here. Const, we already have this written here, right? So what's the use of doing this? We have this much, then we have selection cursor, so let's just simply get that. So selection, or let's keep them side by side so that it's easy to just simply refactor it. Okay, here we are. So selection, we have first of all canvas here, we are checking whether that exists, then we are getting the selected shape. After that we have selection cursor, that's gonna be get selection cursor. We are gonna be passing the point and the selector shape. Once we have the selection cursor, we have to check whether that exists or not. So if selection cursor that does exist, in that case canvas dot style dot cursor, that's actually gonna be goes to selection cursor that is given, and of course we are gonna be returning from here. Otherwise forward shape, if that exists, in that case that's gonna be move, and then we are gonna be updating the cursor. Get canvas cursor, update cursor. What this update cursor does, get canvas cursor, as simple as that. So it's good to call the method here when we have the hover shape. In that case we are just simply setting it to this, otherwise we are updating the cursor shape. Update cursor in the sense it's gonna just simply update that normally. Already I mean this is better, we can go with this as well. Let's go with this, not a problem. So this is also one of the page, but the thing is that pointer dot is panning, and this was already handling this part. So this particular section was already handling that part, so it's better to not have that in here. Or let's go with the previous way. This is better as for right now, no problem as such with this. Avoid filtering every mouse, so selected shapes. Selected shape map, new set, and wow. Instead selected shape map, new set, that's gonna be selected shape IDs. And once we have the selected shape IDs, selected shape dot filter shape, selected shape has the ID. Even better. Yeah, this is also one of the ways that can be used. So ultimately what I'm doing here, that I'm just simply checking that if selected shape ID includes this particular ID. Instead what they are suggesting, that you can actually create a set, so that the set has only unique IDs. So selected shape map, selected shape map, let's go new set, selected shape IDs. Once we have the selected shape IDs, instead of doing this, what we can actually do, that is selected shape map has that particular ID, selected shape map ID. That is the pretty simple thing. Store selected shape in the standard. You already stored the selected shape because you compute the menu, that's right. So what it is saying, they should be stored, and I also expose selected shapes. You already stored this. I'd also expose selected shapes or selected bounds. We are storing that because you compute shapes dot filter, then get the use selected shapes. Now filtering on every point, even better architecture. Get cursor for point over selected scale and tool. Update hover. So whenever we are updating the hover, so get a cursor for a point, we get the cursor for a point, that's okay. This is architecture I'd recommend. Get a tool, get canvas cursor, get a resize handle cursor. That's fine. I mean, this much refactoring it is well enough for now. And this is much better. At least 100 lines of code is enough. Okay, what's the next thing that can be done in here? The next thing is actually refactoring the another interaction. This is the most important part. We have around 200 lines of code and we have to refactor it. So let's see how it can be. I'm just simply gonna ask the same thing, like help me refactor it and all, and then it's just simply gonna do that. Help me refactor this. I have it inside huge canvas. Alright, it's gonna give some suggestions. We have to just simply follow them, create files and all, and just get the job done, right? So let's see how it's gonna be going on. I'm just simply gonna have some code right now. It is just simply not, we have to just simply split the code into functions, keep them where they actually should be, and at the end of the code will definitely be running. From tomorrow onwards, we'll actually focus on more functionalities. Good to just refactor it. I'll be back and then we'll just simply keep reading from here, and whatever suggestions are given, we'll just try to restructure the code a bit better. Until then, bye bye, and I'm gonna be catching up soon.